All right, so okay, so why is this new? Well, this is sort of new, especially this result here, the partial underdog compensation effect, because in some sense it's due to the cost that originate. Okay, so when you this in some sense tells you that the party that's ex ante the majority is the party that exposed wins, which is good in terms of welfare, and which is not the result that standard homogeneous cost models would have. If anybody familiar with this models of rational voter models of the majority knows that there is full underdog compensation effect. So even though the election is 30 versus 70% ex ante, exposed turns out that it comes out to be 50-50. Okay. So why is that not the case? Because suppose it were, then you would have, let's look at the benefit. Was a question? Suppose it were, then you would have a 50-50 outcome exposed, even though ex ante is asymmetric. And so now 50-50 outcome, everybody has the same benefit. Everybody that's voting has the same chance of being pivotal, whether for party A or for party B. So the two parties have the same benefits, same on the benefit side. If they are equal on the cost side as well, that is, costs are homogeneous, then that could be an equilibrium. But if they're not equal on the cost side, then it cannot be an equilibrium because the underdog party has to turn out more. So to turn out more, you have to go fish out people from the underdog party that have higher costs. And so you can't do that because the benefit is the same for both sides, but yep, one party's turn out much more. Okay. So, okay, so but this is good from the point of view of welfare. Okay, so turning out to the okay, so I'm going to turn to the proportional influence model. So this is a similar model in the sense the costs, same distribution, the marginal benefits are what? Is the chance that anybody from party A increases a little bit the share of the power of his party. So without him, that's his share. With him, it just increases A plus 1. And this is just averaged out over all the possibilities. Okay, and the same for party. Okay, so there's some algebra here, and in the end, we obtain a similar result. So there's still partial underdog compensation. On the size effect, though, we don't have two different regimes. We have that the size effect goes down like over 1 on n. So the benefit of voting decreases like n to the minus 1, where n is the population size of the other groups. So what we have is that if we want to compare turnouts, so it's our goal, we will have that in one regime, in the proportional power sharing regime, we have an intermediate, and with the majority we have a slower decline when it's an even election, and a very fast decline when it's an uneven ex ante election. So what I want to take away perhaps is this picture here, which is this is the preference split, and this is the turnout with in majority, and this is turnout with power sharing. Turnout with power sharing does not depend, how it declines with n does not depend on Q. Okay, so we have roughly the same dependence, whereas here with majority, when Q is a half, we have a high turnout because the decline with n is very slow. Everywhere else, the decline with n is much faster. And so the prediction is that if the election is bound to be very close, the turnout will be higher with majority, and if not, it will be with PR and lower with majority or winner take all system. All right, so one word about welfare on this. So if we compare welfare, the two systems, we would have if the election is uneven, ex ante, the partial underdog compensation ensures that the majority wins and gets all the weight in the end system. And so this is dominates the situation in the P system, because in the P system here there's a majority ex ante, we're giving all the power to the majority. In the power sharing system, we're not giving all the power to the majority, so that dominates on the benefit side. Whereas on the cost side, also the M system has a lower cost because less people are voting. So it dominates on the benefit and cost side, so all benefits overall. Whereas in the symmetric system, when you have ex ante even election, then the benefits are the same in the P and in the majority and power sharing, because in majority you have one party will get all the power with 50% chance. In power sharing, we'll get both parties will get half of the power, so we will get the same benefit of one. But the cost is lower in the P system because it has lower turnout. So basically, the M system, majority system dominates if and only if the election is close. So now if I have a few minutes left, I'll go over, we can extend this to many parts, etc. But I want to talk about this in different frameworks. So, because these models usually predict low turnout, and so we wanted to see if this result depends upon the model. That is, in the rational voter model, you have this free rider problem that dampens turnout. What happens if voters, for some reason, overcome this free rider problem and we have higher turnout? Does the comparison in turnout still hold? Okay? So to look at that, we might want to look at two different models of how people overcome this free rider voter problem, which are the mobilization model, say, in which there's two parties, they're just mobilizing voters to vote, and the more voters they mobilize, the more it's costing them. I'm assuming this cost is increasing and convex, okay, and you can't turn out everybody. And in the ethical voter model, it's sort of, it ends out to be similar. It's basically assuming, to cut a long story short, it's basically assuming that there's two sides, two groups of voters with preferences for A and B, and somehow they cooperate and turn out according to, in some sense, a planner. So it's like we're looking for a planner solution for side A, versus another planner on side B, coordinating voters on side B. And so it's basically doing the planner's problem for the rational voters model, assuming they cooperate. We can solve this model, and basically, and we can do it more in general. We can do it for different even distributions here between the two. So not full power sharing, not absolutely winner take all, but some things in between. You could do it in very parametric forms, like the Conf function, for example. And we get the same result in the two models. So the picture again is looks like this again. So this is majority close to 50%, turnouts higher, power sharing turnouts higher if the election is 9% close.